So let's start with the next video lecture video. That is, I'm going to tell the continuation of binary search tree. So here the definition goes like, or we can say the properties of binary. What are all the conditions we have to follow before moving to the any operation which we are going to perform in the binary search tree. So let's start with the first property. The left subtree of a node contains only nodes with keys that are lesser than the node's key. So if your root node is 10, the left side of the root node should be less than 10. Similarly, the right subtree of a node contains only nodes with keys greater than the node's key. Say for example, the same root for the root 10, your right subtree should be, every node should be, the value it should be greater than 10. And the left and right subtree each must also be a binary search tree. Means what? Each node in the left subtree and right subtree should be a complete binary tree. That means each node should have two children, that is left child and right child. So this is the basic condition or property for a particular binary search tree. I repeat, the left subtree of a root node the value should be the less than the root node, and the right subtree value should be greater than that of the root node, and both left and right subtree each should be in a form of binary tree. So here goes the definition. See here, if I say my root node has 8, if you check in the left subtree, the values of the root node is obviously less than 8. We have 1, 3, 6, 7 and 4. Similarly, in the right side, we have 10, 14, 13, which are all greater than the 8. So this is the comparison of binary and binary search tree. While we are performing any operation like insertion and deletion, first we have to make this binary search tree into a full or complete binary tree. That means each node should have two children. See here, if one is empty, we have to make it as a complete binary tree. We need to draw an edge of left node and draw an edge to that of the right node. So here is an example on how we can insert a new node in this binary search tree. Let us see this example. Assume that we are going to insert 40 in the node. So where I can insert this 40? Initially I need to compare with the root node. 40 is obviously less than 100. So I should move to the left side of my root node. So if I move like that, I should compare 40 with 20. 40 is greater than 20. So it should travel in the right side of 20, and it is greater than 30. So I am just putting this 40 in the next to the level or node called as 30. So this is how I should insert any element in a binary search tree. So the explanation which I have given is, since 100 is greater than 40, move pointer to the left child, so that the pointer will be moving to the left child and not to the right subtree. So I am just comparing with the second node. 20 is less than 40, move to the right child, and 40 is greater than 30, move pointer to the right side of the 30 and insert item to the 30 of the right. Now I am going to insert the node called as 40. So this explanation I have told in the first diagram itself. So this is how we can insert any node with the help of this binary search tree. So our basic thing is, first we have to check whether compared to the root node, all the nodes are having less number. The number should be less than that of the root node, and if it is a right subchild, it should be greater than that of the root node. And we can compare. While we are inserting a new node, you should compare with the root node and then followed by each node, and we can decide based on the comparison. We can decide whether we move to the left subtree or to the right subtree. So in the next video, we will see about the deletion of binary search tree. Thank you.